Let's discuss some basic storage concepts. Here are 3 types of drives you are sure to see in the IT field. Today, data storage is typically done to a hard drive. I generally use the term hard drive or simply drive to describe any fixed stationary drive in a computer that stores data. It's readily available and it's used for long-term storage of documents, spreadsheets, pictures, videos, music, and so on. An operating system, also stored on a drive, will store data in essentially the same way regardless of the type of drive being used. That being said, there are some different types you should know for the exam. So here on the left, we have a magnetic-based drive, also known as a hard disk drive or HDD. This is extremely common. It's inexpensive. We've been using these for decades. Here we have a solid-state drive, or at least one type of solid-state drive. These are newer, and the difference between the two is that this drive here uses moving parts. This drive writes the data to microchips, so there are no moving parts. And so this is an SATA solid-state drive, and you can see the SATA connectors here. These drives offer improved reliability over the magnetic-based drive, but you're definitely going to see both. Lots of these in the field. And then over here, we have another type of solid-state drive. This is an M.2 drive, meaning it goes into an M.2 slot. And this particular one is NVMe-based, non-volatile memory express. And I'm going to show an installation of one of these drives in a separate video. And we'll talk about that more. So data can be stored to a variety of drives. A magnetic drive with moving parts, or a solid-state drive such as this that is SATA-based, or a solid-state drive such as this, which is M.2 and NVMe-based. So lots of options there. Hard disk drives, or HDDs, are the most common form of magnetic media that you will encounter. A hard disk drive contains one or more platters with a magnetic surface. Data is recorded to the disk by magnetizing material directionally to these platters. It's done as bits, zeros and ones. So this hard drive is 3.5 inches wide, so this is typical for a desktop computer, but there are also 2.5 inch wide drives used for laptops and for smaller systems. And this has 2 main connectors. These are SATA connectors, a 15-pin for power and a 7-pin for data. Always make sure that the SATA data and power cables are firmly connected. And I show this illustration to kind of push that point home. We have a lot of moving parts here. We have a read-write head, or more than one, and an arm that actually moves across the platter. And the platter spins at 5,400 RPMs, 7,200 RPMs, 10,000 RPMs. So there's moving parts, so there is the chance for failure after a couple years or several years. So that's one of the reasons that solid-state drives were designed. They don't use spinning disks or read-write heads. Instead, they write data to non-volatile memory chips. And today, generally what that means is you're talking about NAND-based memory chips. Negative AND. It's a type of logic gate. Now, SATA-based solid-state drives are generally 2.5 inches wide. And they use the same connectors we showed previously. You've got that 15-pin for power and that 7-pin for data. And you can actually see the pins here. And you can count them out if you wanted to on this open picture of a drive. Now, it's recommended that you keep at least 10% of an SSD free of data. Some manufacturers do this automatically within their drives so that it will increase the shelf life of the flash memory. If all of the memory is used, it seriously reduces the amount of read-write cycles that can be performed before failure. So definitely try to keep 10% free. I actually normally go by the 50% rule with all my drives, regardless of what they are. I try to keep them 50% free. Let's take a look at a couple drives that we have here. And on this system, I'm in the device manager. If we go to disk drives, we'll see a couple drives here. This is a Samsung SSD 850. That is a 2.5-inch wide SATA drive, similar to what we see here. And so that is housing the operating system. Here we have another type of solid-state drive, and you can tell because it says SSD. This one's a 960 Pro. This is an M.2 drive that uses NVMe, and it connects to an M.2 slot on the motherboard. And those use storage controllers. So, for example, this will use the standard SATA storage controller that is built into the motherboard, but this drive will use a special NVMe controller, which is separate. And that was actually a separate download. Let's look at another system. This is just an image of a system that I have here. And if we look at disk drives here, we see that it says ATA. That means that it's a magnetic disk, right? A hard disk drive. So this one has two of those there. And we have the SATA controller down here that controls those drives. Okay, so there's a little bit about solid state drives and magnetic drives. But just remember, there are a variety of drives that you're going to see out there. You're going to see those magnetic drives, you're going to see those solid state drives, and you're going to see those more advanced M.2 based drives or PCI Express drives. And I'm going to show all of those as we go through the videos.